here, whether we're live on YouTube. I always double check on YouTube here whether things are coming in. And there we are. I think I'm just gonna go here to, yeah, I see testing 1, 2, 3. Yeah, looks like it's how's your audio, Chris?
Inbound is fine.
Okay.
Was this on the outbound?
Yeah, I'm just checking to see if the YouTube audio is going through, and then we'll get going. Welcome, everyone. Okay, perfect. We are good to go. So, welcome everyone to a special live stream on this Thursday. I'll continue with my regular live coding at some point this evening. It was fun, but today we're going to have a very special interview with Chris Condren, one of our core advisors at Adaptec Group, and now the current CTO at Power Models, which we'll talk about. And he is also the former CTO of Event Store DB, which is now called Current. So nice to have you here, Chris.
Great to be here with you.
Yeah, always a pleasure to discuss stuff. And I think we met for the first time in person, I think, in Vilnius in 2015, the fall of 2015, something like that. Right. So it's been, Chris, it's going to be 10 years soon that we've known each other in person.
Wow.
But obviously we've exchanged ideas and such many times over on different forums, being passionate proponents of event sourcing. So that was always a pleasure to discuss those things with you, and then to, of course, work with you on a number of things. And today we're going to be discussing dynamic bounded context, which is the idea of having the transactional boundary, if you will, that we find in domain-driven design to be dynamic. Basically, take the entities, take the events and or properties of events, and lock down those that you care about for the purpose at hand, and kind of move away from the traditional object-oriented-ish kind of aggregate approach from domain-driven design. This has been a hot topic in event sourcing circles. So, yeah, maybe Chris, you can give us an intro to what that means. You can share your screen, and I'm going to quickly try and, or we can talk about it. Let's discuss it first, and we can point to that. So, first of all, what is your take on this? And we can jump to some sort of a screen share after to look at some articles and some diagrams.
So I don't really see, to my mind, the dynamic bounded context question isn't really, well, let's talk about consistency and consistency boundaries.
Mm-hmm.
I come from a financial services background in my original introduction to event sourcing. And so I don't really see it as an OO construct. I see it as a data, right?
Yeah.
And having built databases to do event sourcing and worked with a lot of stuff with data in other areas, I really see it as a data and system consistency problem, especially as, in my experience, most event source systems I've built have been distributed.
Yeah.
Right. And so how do you guarantee a distributed system's critical consistency points, right? Without having to worry about, I've got one instance or two instances running. And that's one of the great things I found with event sourcing is I can run multiple concurrent instances of processors on invoices or accounts or whatever. And I can lean on the database for my central source of record to ensure I'm always locking updates.
Yeah.
Right. And so that's been a great benefit. But then, also with Reactive Domain, I took all my tools, really, and I created a framework for event sourcing called Reactive Domain, right?
Yep.
And so I've also built frameworks. So the other half of this question is, how do you build a framework to make things easy? And what does that start to entail? Because as soon as you start doing that, you have to simplify, right? And so it's very easy to simplify event sourcing to say, okay, I'm going to do an aggregate per stream, right? And it's going to have a type, and it's going to have an ID, and then all the updates on that aggregate are in one stream, and I get this nice, simple consistency lock on everything.
Yep.
Then we saw people put too much stuff in an aggregate.
Yeah.
Right?
God class, right?
Yeah, and everything just piles in, and now it's like, oh, well, it takes us, 15 seconds to load the 10,000 events that are in this aggregate, and you look at, oh, well, what's in there? It's like,
Yeah.
well, all that shit none of it needs to be consistent.
Yeah.
Right? Why is it all in here? Right? Or people don't realize you can do indexes on types of events. Like, maybe I just want created events. Why am I going to scan the entire log when I can just take an index and say, give me all the created events? And now I've got a stream that's 20 items long that shows me the 5 things I built.
Yeah.
Right? And so people think the only way to read things is to go by stream or to go by the entire log, and they don't realize they can reposition things into these different contexts. And you want to keep all your aggregates really small and reassemble things on the read side, right?
Yeah. Yeah, exactly.
And with event modeling, you even make that more clear to push that even farther to say, we don't even need to specify these aggregates, right?
Exactly. So, I mean, an aggregate you can do in event modeling if you want. You can have swim lanes down below, and then sub swim lanes within a swim lane. So, as an example that I give, it's always an order is the aggregate, and then the actual components of the order, such as adding a line item for the order that has a product or a shipping method, an address, a client code, and all of these different things are components of an order. And this is, I guess we could say that also touches on the tell, don't ask principle of not trying to manipulate the internals of some abstraction, but have a gateway to interface with it, for lack of a better word, not just transactional integrity, but also having a control point so that you don't have things being changed by accident, people going in there and changing details on you when you're obviously working on a code base that isn't event sourced, and you don't have that multiple model approach, decoupled model, the level of coupling where it's controlled, where you don't have a lot of control. You're trying to reuse a single abstraction for multiple purposes. That aggregate root was kind of not a band-aid, but a solution to having this kind of go unchecked, where you have all of these possible instances of the item, like the actual order item, one of those lines to be manipulated somewhere where you didn't expect it, and then all of a sudden you didn't know that was changing, and now you have a problem with the order. So the aggregate root was kind of a control gate for any of these subsidiary objects to not be missed in case someone changes state. So that's also how I see it. I also see it kind of like coming back from, I mean, we're looking at domain-driven design, which was written around 2003, 2002, I think, when Eric Evans started writing it. And so those, if you look at the landscape of IT work, there was a lot of object-oriented thoughts around
He
all
totally
this.
wrote it with an old approach.
Yeah.
But one of the things that people they miss is Eric's original definition. So his entities had roots, and the aggregate root was all the entities that had to be checked to have a successful database commit, right?
Yeah.
And now people just say aggregate, and they have all these entities, but they don't realize that that was supposed to be the boundary,
Yeah.
right? That if all you needed was this one thing, that's how big it should be. You shouldn't be piling everything in.
That's right.
And I think the other thing to really think about here is why do we have streams at all in in an event database,
Yeah.
right? Um, why not just read the log, right? What
Yeah.
is it that makes it useful to read the log? Because when you talk to people about like, well, my aggregates are getting slow, why are they getting slow? Because you're scanning 10,000 events to get where you want to be,
Yeah.
right? And anytime you're scanning a database, you're slow. You always want to be stabbing. I want to read one event, if ideally, I want to read one event, get what I want, or maybe read like 100,
Yeah.
right? Because 100 events is going to be instantaneous response, right? So the reason we have streams in the first place is to group the events to represent some state together in a way for fast access,
Yeah.
right? Because one of the things that we considered, so I joined Event Store when we sort of rebooted from the open source project into being a commercial entity,
Yeah.
right? And one of the questions was, hey, do we just scrap everything, rewrite it all in Rust, or do we just put it on top of Foundation DB, right?
Right.
And the question of, well, why would you do that is why not use Foundation DB? You know it's scalable, you know it's performant, you know it's distributed. But the problem is writing effective indexes on top of Foundation DB to access events in a rapid fashion and order them becomes difficult,
Yeah.
right? And what I actually found was I really wanted to do was an ordering hierarchy to say you've got your store, and then you've got your categories, and then your streams, and then you have cross-cutting streams, which are these indexes of events of interest, either by type, right, event type,
Yeah.
or by or by root. That gives you the full category, and all those can be virtual indexes on top of your store
Exactly. And
to
then
give you that fast access.
yeah, that
Right.
the access is one part of it, and then of course you have the integrity of being able to find
Right.
a lock that makes sense. Because as you're indexing on different subsets of the events and their properties, how do you now start to lock things where or don't? I mean, it may be that I certainly prefer not locking if I have the choice, and that's majority of the time, and just have a good way of projecting the event history, so that when there was something occurring at the exact same time and you had this possible thing that you might have thought a lock would have solved, it's actually just easier to have a retry mechanism or give an error, and you really have to analyze your SLAs and really say what is the cost of adding the complexity of locking. And so I think this way of looking through the lens of indexes, and then understanding that you're also going to have projections that have these things are going to be part of projections. How do those respond to those potential issues where you don't have a lock, a transactional sort of in the transactional database traditional way of thinking, a row lock on a record, so that you wait until someone
Yeah, you definitely don't want that pessimistic lock. You don't
yeah,
want to preemptively pessimistically lock the database, try and make your update, because then you're blocking everybody else. It's
exactly.
much more efficient to do an optimistic lock where you assume the write's going to work, you accept it, and only if your key breaks do you then kick that out. And you just use vector keys,
Yeah.
and vector clocks. And you can do a vector clock on multiple streams if you need to,
Hmm.
right? Which lets you keep them really small.
Yeah.
Um,
Yeah, it's interesting
and I
how when
think,
you start to design how the indexing will work for your purpose. That you're also kind of answering your own question about like how are you going to treat where you would have had this traditional kind of lock versus allowing things to happen and then just understand that your projections are going to reflect these facts. And I think on my live stream, I was doing exactly that for registrations recently, where a registration couldn't go through unless the conference was opened, and the registration couldn't go through anymore once the conference was locked. And as you're looking at this through a streaming perspective, you can say, well, I have these projections I'm working on, and like, what if I get this out of order? So I have a registration after the conference was closed. I mean, do I allow myself to add this, added quote unquote complexity of having this situation, which I know shouldn't happen, and maybe I implemented that correctly, but it was actually easier for me to not go and create the lock, but to say that, okay, if I have these out of order, it's easier for me to say that, well, I'll assume that I can just ignore this thing that came in after the conference was closed, because that obviously shouldn't work. And when you look at a stream from left to right over time, you can ask yourself the questions from a business perspective. Is this going to cause a problem? Is this something that is unexpected? And those answers are actually a lot easier than implementations, because you can just say to yourself, yeah, that's fine. I mean, we're just not going to bother looking at this one that came in out of order. We're just going to break out of this case statement when I'm going through the list of events that are coming through. And that's my rule for this projection for these events that follow, that are optimized by this index. So we've been spending a lot of time talking about the indexing part, which is a lot, I think in people's minds, at least my mind, it's a little bit more on the reading of these events, which is one thing to get them fast, etc. But then we also have the transactional component where we do need to lock or have some invariance for not allowing new events in unless some conditions are done. I don't know if you want to switch to a screen share.
I've got some walkthroughs I did for a conference talk in Kansas City.
Yeah, let's
really help.
Yeah, go for it and screen share, and I'm going to switch this for people to see.
So the one thing that I would say is, generally, to your point about the rules and the business impact, my rule is I don't allow the system to act on behalf of the business incorrectly, but I always allow it to record information, right? Even if it breaks the rules, right? Because if you think about even what might seem to be a simple rule, like I've got a warehouse and you can't ship more inventory than you have. Seems like a really simple rule. Well, the truth is the warehouse is for real. So suppose we have 3 items that fall down behind a stack. We do an inventory, we write them off, and then a week later, we pull the stack out and we ship all of them, including the 3, to make an order work.
Right.
So if the guys on the floor at the warehouse say, no, we have 27, the system should not say, sorry, you can't ship 27 because you only have 24 listed.
Right.
Right? It doesn't make any sense. But that's very different from the system saying, hey, I'm going to send you 27 when I don't have them. So is the system acting or is the system recording? And it should always accept recording of things, but it should generally not act without the logs.
Yes. Yeah.
All right.
Yeah, let's see if we can. Okay, there we go.
This is
oh yeah, maybe we should go a little bit on the background of currently what you're doing, and then do a little bit of an intermission. And so
what we do is we have an Excel interface for a fully event sourced small and medium business analytics suite.
Okay.
And because it uses Excel as a UI, you can do any schema you want, anything you do Excel, it all works. And because it's event sourced, you can also get full fidelity, history, audit. We've built all those things you always hear about right into the product with a very simple user first self-directed sort of approach. And we not only give you quick templates and blueprints that let you track where you've been with cash and where you are with profits, but also where you're going with opportunities and forecasting, all in one simple timeline. And the timeline we produce is actually very simple to the timeline you see in event modeling.
Yeah, I think
Um,
people don't realize just how much Excel is used in
yeah,
places that are in the fintech space, especially. That is the most common interface for these domains, and to not have an answer for it is it would be a miss. Let's just say,
and so that's why we chose it as our UI. We're also going to be adding Chrome and
yeah,
other spreadsheet support. It's not Chrome, Google Sheets as well. Because we
yeah.
really have a backend engine that does all this. It
Uh,
just projects into the spreadsheet.
and I remember this was back in 2004. I mean, a long time ago now, but there was an entire company that did energy trading in
Yeah,
British Columbia. The entire business started with spreadsheets,
yeah,
and it continued to the
yeah,
point where they had a Oracle backend to a really large enterprise operation worth billions of dollars, probably the largest public company in British Columbia at the time.
yeah.
And so when people say, "Oh, that's it's a spreadsheet," what kind of a Mickey Mouse thing are you doing here? Well, the
Oh yeah,
largest
no,
the largest fintech companies work on spreadsheets.
um,
That is the interface. Sorry to say. So
I've,
this is pretty awesome
I've
to
seen,
see that you're doing
yeah,
this.
I've seen companies manage hundreds of billions of dollars in spreadsheets.
Yeah.
It's just unbelievable. Um, and that's the kind of scale we're looking to get to eventually. But right now, we're rolling out with, the first customers we're going after is solo and small businesses,
Yeah.
and then we're going to move into mid market and move all the way up.
Right.
But
So, do you have a small little demo or something else you want to show before we continue
not
with
right now.
DBC? Okay.
We've got a bunch of stuff we're gonna have coming out next week. It's gonna be really really exciting.
Okay.
We've got some AI we're adding in, and all that. And so if I get back, I'd love to give you a quick demo.
Yeah, that would be good. We can also do another stream to see the progress. That would be really cool
Yeah, no,
because,
that'd be awesome.
yeah, I think a lot of people in the fintech space, accounting and other domains, have spreadsheets as part of their daily workflow. So to have event sourcing at the core of that kind of system is incredibly helpful. Especially with these scenarios and what if scenario. It's one of those things that of the original event modeling article that event sourcing article that Martin Fowler
Yeah,
wrote back in '05. We're only finally now kind of using it a little bit more actively for the what if scenarios, which is one of the propositions that was made in that article so long ago now, 20 years ago. So yeah, really cool stuff.
it's
So
one of the
did you?
reasons that really inspired me to do power models was I was building a database, but I really wanted to just build the products that I've been building for years and really show people what event sourcing could do. Right? And people keep on saying, "Oh, you can't do this, you can't do that." They say it, but never see it. And I just want to, well, let's just show you.
Yeah,
Let's, give you, so I can give you a tier one banking experience with data lineage and history and what it, as of and as at, all in Excel in a small business for, a fraction of the price for stuff that they'd never be able to build themselves.
yeah, yeah.
So,
It's pretty awesome. Is there do you have any diagrams for DBC? Maybe from a presentation or anything like that, or do
um,
you we can just discuss it?
we just discussed, I mean, I've got the first thing I want to talk about was how stream storage actually works.
Oh, sure. Do
The
you want me
indexes
to
get
keep
built.
sharing the screen?
Yeah, yeah.
Okay, let me go to that. All right, go for it.
So this is I like this picture. This is a physical Turing machine,
Oh wait, I
right?
see the old screen still.
Um, I mean,
Okay, reshare the other one and
How's this?
Good. Yes. Now we can see it.
Okay, cool. All right. So that's why I was moving through my presentation. It wasn't showing it. Okay.
Okay. So did we miss a couple of slides?
So this is actually a physical Turing machine, which I really love because that's really what event sourcing is.
Mm-hmm.
The first logical machine that all of computing is based on, right?
Yeah.
Where you got the tape, it goes through and it gets written on, right?
Yeah.
And this is what most frameworks do: is you have an input, you have an internal state, output, and that goes into your history, which is your stream.
Yeah.
Right? And so if you store at the top your command sourcing, if you store your internal state, you're either doing snapshots or changing it to capture. And it's only if you capture the output or the business decision are you event sourcing, right?
Yeah.
Because what we want to do is we want to separate out what we store as the business domain, the business model, and what happened for the business. And we don't want to tie to our code or how we did it, right?
Yeah.
And then the way that gets persisted into a database. So we have the event log here at the bottom, right? I don't know if you can see my cursor
Yeah.
or not.
Yeah. We can see. I think. Well, I can see your cursor. It kind of flashes here and there, but yeah.
Right. So the event log is the master log with all the events, and then we're going to have several physical streams that are the primary indexes, and then we're going to have another index which is indotted, which is going to be a projection or a virtual index, right? And so as I write an event into the log, I also write into my primary stream. This is like writing into a database and writing into a table. So if you think about the table and the stream, it's very similar, right? And the event log is the files on disk for the database, right?
Yep.
We can see we're creating a master sequence, and then those events are each going individual streams. And now I have an event you can see that's position 4 in the master log, position 3 in stream 1, and position 1 in our index 1. Maybe that's a warning event or an alert event.
Yeah.
And so this is how we build up state all the way through the application.
Yeah.
Right? And this is what's going on sort of under the covers.
Mm-hmm.
And then the way that works is we have our aggregate or our service, right? I try not to use that word aggregate.
Yeah.
We have a service that reads the private state from one stream, right?
Mm-hmm.
Takes an input, evaluates the current state, produces an event, and writes it back to that stream. And by using this stream logical clock, we know that we should be writing, because we've read to position 5, we know we should be writing to position 6. And that gives us our optimistic concurrency logs, right? So only if the stream has moved on and someone else has beaten us to a write do we have to worry about concurrency.
Yep.
Otherwise, we just move on.
Mm-hmm.
Everything else on the read model, the readers and the derived state, they read from everything. It's only the writers that restrict themselves to that one stream only.
Exactly.
Right?
Yep.
And even with the dynamic, context boundaries, there's still going to be something you're writing to that's going to be your primary stream.
Yes.
Right? But I think what they're saying is you can make those smaller and you can do your process checks on an index read, right? Rather than doing them only on reading the stream.
Yeah.
And this becomes important as people start putting too much into a stream, too much into an aggregate, right? The other thing that we tend to do in a good event-sourced data storage system, right, is we're also going to create categories and hierarchies, right?
Yes.
And so one of the ones that gets built automatically in Event Store or now current is the categories, which create a virtual hierarchy of the streams. So if I've got, say, customers, I have customer 1 and customer 2. The customers index would be all the events from both streams in order,
Yes.
right? If I invoice is the same thing, right? The other very common projection that you can get built in is by event type. So if I want to do created, if I want to do closed or failed or alerts, one of the ones I use all the time is like you could drop money laundering events, money laundering warnings into a banking account system.
Yep.
And have a separate stream that works on those. That's entirely separate from the managing of the account. And it's just these alerts this other group uses. And you just drop in the same stream.
Yep.
And they work. And then here I can go on to the relationship between event sourcing and relational. There's a full mapping between third level form and a well-defined event schema in a event database. But that's really out of the scope of what we're talking about here. I think we're just really talking about what do we think about when we're talking about dynamic bounded or dynamic context boundaries.
Yeah.
Is just shrinking those streams down, not loading everything up, and being able to use an index to do my validations. Or a projection rather than only using the core stream.
Yeah, and I think there's some benefits that people, they're saying like, well, why would you do that? Is it just to not feel constraints? But it's also really a good way of extending systems. I think someone had a good example of a dynamically bounded context for introducing something like ratings of products. Let me get you back onto the screen here. And by the way, there are some questions that are coming up in the chat. So I think we can get to them at the end, right? So if people go onto the Discord channel, the live interview channel, or they're on YouTube or X or LinkedIn, if you comment, we'll get to your questions probably at the end, or we can interrupt something if it's on topic. Someone was saying that they're curious if the resource event agent REA accounting is still valid in today's market. So I haven't heard of this really, or maybe I have in not so many words. But the Wikipedia thing says that it's, let me just share my screen, and just so people understand what I'm looking at here.
Focus my camera.
Okay, don't worry about it. It's fine. It's it'll. I think your picture is small enough so the focus doesn't matter for most of these. But this is what this person's asking about. Oh, I can actually change the appearance of this.
So one of the I think that the dynamic context boundary to my mind immediately jumps to is MongoDB, right?
Oh, right.
So if we're thinking about so I've been talking about the formal structure and relating to SQL and database locking, which really coming out of finance, which many of the original use cases did come out of.
Mm-hmm.
That's really important. I don't want to initiate a trade for tons of money when I don't have it, right? If I place the same order to sell shares with two different brokers, I'm in trouble, right?
Yeah.
But MongoDB is a really powerful database that doesn't have those same constraints. It's generally run with a loose schema, without the locking, and it does tremendous work. It's tremendously powerful. It covers a lot of scenarios with the web. You don't need that kind of stricture. It's not the only way to build good, successful, functional applications.
Yeah.
Right? And I think that's one of the things I see that people are so railing against is hey, I'm not building a trading app. Why am I locked in to all this formality when I don't really need it?
Yeah, exactly. Right? Yeah. I think because we've been traditionally using a regular database on the back end for any of these things, we kind of automatically assume that that's what we have to work with. And so one of the things I'm trying to do on the live streams is say, let's just look at the information coming into the system. Do the system's thinking, what do we capture at the border? What is in the system now? Can we just look at it in its raw form for all the different purposes it'll serve, and assume we don't have indexing, assume we don't have locking, assume we don't have mutexes or whatever else might be used in these systems? Let's just see what, at the raw level, what can we look at? And it's kind of similar to how simple Git, the source control management tool, is. It's really focusing on having a very strong convention of how you have content encoded IDs, so that references are always, not pointing to something that's missing, and if it is, it's fundamentally broken. But this convention really simplifies things, and you need this simplicity to scale systems, right? To make something quite large, but it's already complicated and complex. It's just, that's working against you every time you try to make it work for more users and especially concurrent users. So I think the simplicity of event sourcing, of just having this, idea of what are we capturing at the border, is really powerful. And so I want to go back to the example. I think the example was, and I'm not sure if it's written up. If I find the article of someone discussing this, I think they were doing product reviews or something, and because someone purchased something, that product is on a line item, so the core of that purchase is product added to order, but now from the lens of reviewing what you bought, that's no longer an invoice constraint. It's really about all the products you've interacted with. There's a whole new boundary here of all your purchases, and not only that, but it's excluding where it got shipped to, etc. Those are all irrelevant. All those events are now irrelevant, and also some of the components of those events, such as the quantity even of how many you bought. To review the product, you don't need to care about that you bought this twice, 3 times, or 4 times on a single order. The fact is, you either like this or you don't. So you start to really see this dynamic boundary of this concern. Do I really need to now think of a much better abstraction for what I consider, quote unquote, a product from the user's perspective, right? These are the things that challenge the traditional thing, where you would have a table and reviews listed for products, and it gets into a whole bunch of scary database relationship problems. Whereas in event sourcing and a dynamic bounded context, I can have an index of just what I need and make that projection, and I can even do proper locks on whether I purchased this yet or not, and things like that. Does that make sense as an example?
Yeah, totally. So I'm thinking about running through that. I think that the idea that you would put the customer review on the invoice is just insane. Right?
Exactly. Yeah. But a lot of people are doing that because they look at the database schema and what they thought were the primary key and the foreign key and this table and that table, and they well, this stuff, these purchases live as line items on orders, so I have to now make some weird, crazy intermediate table that relates order item, line items on an order to reviews, which is just insane, right?
It's like just shared keys, right?
Yeah.
Like if I have a product I would just create another stream, which is reviews, and use the same product identifier on the review stream, and then the system knows, a review with this product ID as its key is the same as this product with this product ID.
Yeah.
And now I have 2 entirely independent streams. They don't lock with each other at all. And all I have to do is check that the user has bought the product. So I'd assume there'd be an event in the user stream saying I bought this. And that's all it is. Purchased with an ID.
Yeah,
and then
exactly.
Another event to the review stream on the product with reviewing the information and the user ID.
Yeah, I mean, it's what information, we look at the systems thinking and you think of it from a very simple perspective. I reviewed this product. That's my event that I store. I don't have to worry about how someone wants to put that in a table or some other part of the system might want to look at this type of information. That's the power of event sourcing in these dynamic bounded contexts, is that now I have, total freedom how to interpret that. But the systems thinking kind of has rescued me from a lot of complexity up front, right? I'm just saying that, hey, I'm Adam, I purchased this product and now I reviewed it. I gave it 5 stars because I like using it. Do I care which order that was in? Do I care how many I ordered? Right? All of those things now are, not my concern. And I didn't have to refactor my solution to make that work. That's the important part, because I think people that are listening are like, well, you could make it work if you now change your database schema to be such and such and blah, blah. Like, no, I don't want to do that.
So
The bigger your system, the bigger that question is of how you're going to refactor this and triple check that your unit tests are failing or passing. And no, thank you. Been there, done that. Never again.
So let's take a semi-real world example. So we're selling this product, right? And we have all these invoices and we have all these sales. We have all these customers that bought it, and we have all these reviews. And then we get a bad batch, right? And we want to know, we want to separate the reviews on the bad batch from the reviews before and the reviews after.
Yeah.
Right? So I see a lot of people that would then start creating events that would then capture all of this information or link them all together or put them all in the same aggregate. And it's like, no, that is all a read model side. Right?
Yeah.
I want a short, simple stream for an invoice and a sale. Right? I want a short, simple stream for the user and a short, simple stream for the review. I just want to have the keys I need to build a read model that I'm going to run to answer this question, right? And then I'm going to query the read model to get the answer.
Yeah.
Because I can assemble that whole timeline from the events if I need it.
Exactly.
But I'm not going to code that into the right side.
Yeah.
That makes no sense whatsoever.
Yeah. Right? And of course, we do this from, people are, I think a lot of times, getting back to event modeling and actually showing systems like this working over time. So for those that don't know, we do event modeling as a way of designing these event source systems, but all systems anyway, by just walking through the use of a system and actually showing that systems thinking boundary of what's coming in, what's coming out of the system, how are these pieces of information stored in each different service within the whole system. This kind of stuff actually plays very well with event modeling. And I think people that have been around for a while, I think, okay, event modeling is heavily based on a domain-driven design and a particular way of working with aggregates. And that's entirely not true. It's compatible with that way of doing it. I can restrict my event model to show only certain events in a certain swim lane if I want. The linking between, okay, I have these reviews linked to these projections, these green boxes for showing things. And I also have these events linked to how, this particular next event is going to be stored if I want to change something or add another review. Like, hey, you can't add a review for that product because you already did that, or you returned the product, or you never received it, you canceled the order, or whatever the rule is, right? So you can show those there, and so when people are discussing these dynamically bounded contexts, using event modeling to show that is just fine. And I think I don't know how one would even attempt to do dynamic bounded contexts without event sourcing. I think you could do it, but I think it would be incredibly clumsy. I think you'd just get a Quasimodo version of. I can see it. The only way I can see it is that you would have a table for each type of event. You would have a master table that shows the global ordering of these entries in each one, which would have an ever-increasing number of columns so that you could reference every additional type as you add it. And So yeah, you could see how that's kind of clumsy, although it would work. You could then have views over that schema that would tie together, you know, certain queries.
Usually you can make it work, but it's not going to scale. It's not going to scale for really small cases. Not like, oh, you couldn't run
Well,
a
let's explore that.
whole
Why
application on it.
can't I relax the default foreign key relationships to make it scale and have 3 or more instances for the right side, you know, your odd number of master nodes, and then can I federate out the projections that are showing me views for the purpose of reading information? Let's take SQL Server as a default database. What would it take? I want people to understand just how much they gain by doing event sourcing properly. If they try to do the same thing with a traditional system, what world of hurt are they asking for? Let's look at some of the default things of turning off row locking. That's, I think, the default in SQL Server, and other things to make it scale, to do dynamically bounded context using a regular database. I mean, I don't know. You're the expert on the indexing, so I'm asking you because I can imagine. I've worked with them. I have a glimpse of the complexities involved, but I want to hear your take.
I mean, the main reason why I was like, that's not going to scale is think about how you key that table to be able to do a query, right? How do I write the indexes, right, on that one table as I'm auditing columns and rebuilding those indexes just to have an efficient query? I'm not scanning the whole table to know what's going on every time I want to do something, right?
Mm-hmm.
That's the problem is, and then every time you do a write, once you've got like 6, 7, 8 indexes on it and constraints, now we've got to satisfy each one of those every time we write. So it's just going to start tying itself into knots. And as that table gets bigger and bigger and bigger, that problem compounds with growth. It's not a linear growth problem. Right?
So, but wait a second. Isn't there a way to do? Yeah, aren't we going to have an ability to grow an index without doing a table scan though? In a modern SQL Server thing, do they not have?
But you're saying you're talking about dynamic compounded context. So I'm translating as you're going to have new contexts you're going to be adding, new fields you're going to be adding, right? So every time you want to add a new context, if you want that to be efficient, now you're talking about a new key, a new constraint, something else you're adding to it.
Okay.
Right? That's where my mind is going with this. Or you're pushing all your constraints to the app. If you want to have all your constraints on the app side, that's fine.
Yeah.
But now you have to have all of your app nodes decide what they're going to write to the database together.
Yeah, so you're basically, so then you're basically implementing your own Paxos in essence to
exactly.
Okay.
Right. So now you're not leaning on your data store to get consistency. Now it's in your app. Now you need Paxos. Now you're doing all this stuff, and the whole point here is to be simple.
Yeah.
Right?
Yeah.
Whereas, basically, if you've got 2 events in a stream that don't, the only reason to have things together in a stream or an aggregate is to enforce constraints. You don't have a constraint, so we'll put them in the same stream unless it makes your life easier, right? So default to having things spread out to where the constraints are. And those constraints, right? If you say, I find it useful to say, I only let an aggregate read one stream because it tells me where the stream boundaries are. And so I try and push things into many different streams as I can while being able to enforce the constraints I need, right? And that's how I get around this. And I think people that use that approach don't feel this strong need, right, for these dynamic context boundaries. I think it's people that are in the frameworks and the approaches are pushing them into folding everything into one stream. and then they're getting in trouble, and now they're in production, and now they're worried about like restating their database.
Right.
And in terms of restating your database, it's a little bit difficult,
Hmm.
but it's actually like a couple days of work to write the transforms that can completely restate your entire database into new streams that your software can pick up and use just fine. And most people are used to like restating a database as being like a multi-month nightmare project.
Yeah.
They just don't realize that the alignment of the events makes things possible if you get that far into trouble that you otherwise never would have thought you were. Right?
Yeah, I mean, we're looking at a very specific benefit of event sourcing, but it actually just starts to touch on the other overall benefits of schema migrations and just being able to do proper versioning of your entire system, and it starts to get into, well, as you have these dynamically bounded contexts, it's really they start to show up as you introduce new features where you want to have like the product reviews and things like this. And so this is inherently part of the schema migration problem, and where you have the horror stories of traditional systems with their schema migrations that absolutely paralyze entire projects because they're just too difficult to do. And once you switch over to this systems thinking of capturing things in streams and really being one of the things that people don't realize why it works in event sourcing without a problem is that you're forced to do the migration right now, or things won't work, because even as you're developing the new system, you have to see that you have the old schema of the events, of the streams and all of that, and you have to do it at the most responsible moment, which is the minute you introduce something. I think what happens with traditional stuff is that you say, well, we're working on version 2, and here's the beautiful schema we would like to use, and look at these new features and everything working together so well with this, and they have no clue at all or about how that's going to impact the old schema, and the data sitting in the old schema. And, well, we'll take care of that when we're releasing. Famous last words. And then they're now reverse engineering how the hell that could have ever occurred with the 10, 15, 20 features they kind of assumed were going to fit in with the old data and the old schema, which is absolutely irresponsible. And it's a real blind spot, I think, in the industry, which is slowly, getting uncovered as more people adopt event sourcing.
People are so used to the pain, and there's like 40 years of how-tos to deal with it, that people have forgotten you don't actually need the pain, right?
Yeah.
There's a reason why I find that anyone I've worked with that's been on one successful, really, successful event sourcing project never wants to go back.
Yeah, exactly. It's a one-way street. It's same thing with Linux and open source stuff. Once you get out of the where you've been pushed to by either vendors or status quo or established practices, and that's kind of unfortunately how we have to push the world forward. Is there's the people that want to and can afford to take the risk to try new things and do that, and obviously you yourself have done that extensively. I mean, going through and you're there's very few people in the world that went in and did event sourcing as the only way of doing things, and you're one of those people that I know that have done that, knowing that you've taken the red pill in the matrix and you cannot get back in the pod to work in a stupid way anymore, right? So and
it's all, for me, being in finance, there's all these what I call level 0 requirements.
Yeah.
It's got to fail over, it's got to recover, it's got to audit, all these hard things, right? It's got to distribute. And with event sourcing, they're all easy.
Yeah.
So now, rather than spending half my time working on the idea of what I want to build, and the other half building all this crap to make it scale.
Oh yeah.
I just build what I want to build, and I'm done.
Yeah.
And it automatically does all these other things, right?
Yeah, I mean, one of those. I mean, the proof for me was incredibly quick. I mean, the minute I said I wanted to work this way and started my own company to only do those things, I realized what I didn't have to do anymore. And it's like, okay, I can see how even as a single consultant growing this to have 2 or 3 consultants and growing the business, that I could be way more nimble to be able to adjust how I develop products that I don't really need. This is where event modeling came from, really, is on the back of event sourcing, is that I could think in a way that is business friendly. I can think about the things that are more human friendly. The sequence of events is a story, and the successful parts of anything that we do in systems, or even to sales. Sales is done by sharing a story. The reason stories are important is because they one part of the human mind and communication is just how much you recall. It's one thing to communicate and get the words across, but it's another to make sure that those words stick and you remember what was said and you get the idea across to be permanent. And I think that event sourcing is really like that. I'm starting to realize, looking at traditional systems, when I have like WUMP, here's the current state. I'm like, how did we get into this state, right? And now when I look at systems that we work on, it's like, WUMP, here's the history of what happened in the system where we are right now, and we're looking at this screen, we're at this part of the workflow. That timeline mindset, I mean, it's amazing to see how long we've gone in this industry with that aspect not there. It's really it was a tightrope walk for a long time, and now we're on solid ground with the reassurance of knowing how we got to where we are, and you're not gonna fall over.
And it lets you solve defects and know what to do next.
Mm-hmm.
And all those things become easy because you don't have to worry about all these different options. It's like, here's where I am, here's how I got here, here's where I go next, right?
Yeah, and think about this from a testing perspective too. If you're, I've realized now, and this is not just myself. I think there's people that we have some senior people that worked at AutoTrader, and they saw this at scale, where the event stream itself allowed production issues to be solved so fast, with so many different people that are non-programmers, such as support people, being able to say, we got the support call, and we know that it's this thing that happened at this time that caused the issue. So they're actually telling the developers how to solve the problem before it even gets communicated and dispatched as a ticket or anything like that. And so I know empirically that event sourcing is 10 times as valuable as unit tests, because there's no way to cheat an event source system, because the stream, the log, is the truth. And there's so many like test beds that are like have ignored tests and flaky tests.
Question for you.
Sure.
I think I know the answer. If you had to give up event sourcing or unit tests, which one?
Easily unit tests any day.
Right.
100%. I need the breadcrumb trail. It's like accounting. Right. Like, tell an accountant to lose the books on how they got to a certain situation. It's a ridiculous proposition, because, well, I have this tool, I have this awesome calculator. You can have this awesome scientific or accounting calculator, but you have to give up, your record of account.
Right. Yeah.
Or you can keep your record of account, but you have to do all your calculations by pencil. I'm sure any accountant will say, I'll do it with pencil as long as I have my, record of account of how the hell I got here, because otherwise we're going to file the wrong tax things and we're going to be out of business. Same thing with information.
And somebody's not going to match.
Yeah.
And with a calculator, I have no idea where it happened.
Yeah, right? and I mean, people.
With all the events.
Yeah, so there's a difference here. I think there's a lot of history of computing that is the infrastructure, the evolution of like how we do, scaling, like the nitty gritty of like what happens at a processor and compilers and all that. But then there's the other side of it, which is like, what are these things serving? And those are information systems, and they're no different than they were when they were pen and paper. For what you're tracking, you still have the same business that does insurance, that does, it's a point of sale system or whatever. They're the same, and they need that record of account. And so I think people were trying to apply computer science-y, concepts to accounting concepts. They just don't work. They're not snapshot algorithm problems. They're record keeping problems. Entirely different set of requirements of how you do that. And that's my take on it. But
Yeah. So
I don't think I was so. It took me a long time to
around
get convinced of that. Believe it or not, like a lot of people don't realize how ingrained the computer science, academia, puzzle solving way of thinking about computers has biased us to a way of working incredibly inefficiently and really needing to have a lot of support. Oh, we need these, we need the testing pyramid, we need this and that, we need automated tests here, we need CI/CD, we need this separate Jira tracker, we need this and that, we need retrospectives, we need database migration schemas. We don't need any of it.
I mean, well, so I remember I was when I first got started, I was a QA architect, right? This is, way back in the day, I got started building test tools for the telephone companies.
Yeah.
Right? And then I started doing presentations and talks. And I was talking to one company, back like 15, 20 years ago now. Jesus. And they were touting they had fired they had no QA staff. Right? They didn't need QA at all. And so I started talking to them, right?
Oh, what do you have instead?
What do you guys do? How's your day work? I was like, well, I write a feature and I review with my other developer, and he checks it out and makes sure there's nothing wrong with it, right? And then we check it in. I'm like, okay. So what you're saying is the QA function is in the dev team, right? You don't have dedicated QA people, but you still have a QA function.
Yeah.
And so I think you still need testing, you still need migrations, but what goes away is all of these off-the-shelf giant boilerplate things, and what actually solves those things now is much simpler with event sourcing, right?
Absolutely. That's the best way to put it, because people, when they hear me say it at an extreme level, is that we don't do these things. We don't have a safety net. No, you have unit tests because it's a safety net. We have a better safety net. So I have a safety net that's so strong that I can not bother with unit tests. That's crazy, right? People are like, how the hell is that possible? And the other reason that that's possible, people don't realize, is that there's a heavy leverage of open-close principle in theory, that once you're finished with a workflow slice, that thing is immutable. Like if I'm changing the design of the system, I'm wholesale replacing that piece. So what does that mean? What are the odds that I'm going to have a unit test fail for that piece as I'm running in production? Zero, nothing. It never happens, which is crazy.
The other thing that happens is you have such clarity on what's going on as a developer from the event stream that you run into these cases where you miss something far less often. Now, I'll say that we got thousands of unit tests in what we do.
But we do as well. I'm not saying we don't do we don't do unit tests. Our customers demand that we have unit tests, so fine, we'll have them. But honestly, if you went into those solutions and just wholesale deleted all existing unit tests, I can guarantee you that because of this open-close principle approach, if it ain't broke, don't fix it. Our refactorings don't ever touch previous functionality. Everything's additive only. So I'm like, yeah, go ahead. Just delete the 1,500 unit tests in this solution, and I'm still happy to support it in production. I don't care. There's very few people that can say that.
I'm one of them. We're dealing with slightly different use cases and domains, right?
Well, I
And
don't
so I'm
know. I
not
mean, we've
saying
done
that.
a crap load of domains. This is going from
Yeah.
insurance to point of sale systems to even driving instructor. We had a driving instructor software that we built. So we've had hundreds of projects. I would say if we include all of the startups that we tried to help and all that with good ideas and all that. In terms of really large projects, we have a page full of really large you know, large scale things out there. And yeah, you can't switch the whole world overnight. But I know
So I
that,
understand.
and even on the live stream, I've had this where the unit testing mindset, because we're so brainwashed to thinking you must have unit tests. You must. I'm not anti unit tests, but I'm seeing them as really optional because there, it's like unit tests can do no wrong. But that's absolutely not true. You can actually go and gold plate via testing and say, and I went through that. I said, especially with this registration thing, I said, well, what if this registration ID gets submitted again and this happens? I started to make crazy scenarios that actually would realistically never happen or had a 0.01% chance of ever happening. And it actually screwed up how the AI would help me in terms of testing. And AI is kind of like your rubber duck. It's kind of like explain it to me like I'm a 5-year-old. And if you have crappy requirements, it's going to give you crappy results. And I actually showed the whack-a-mole bug based on
Yeah.
shitty requirements. Guess what those shitty requirements came from? It's me gold plating using unit tests. The other slices that I did without unit tests, like that, one after the other. And guess what? If I see it working once, why would it stop working? Tell me why in an event source system, when I wrote that command handler once, tell me why next week that wouldn't work.
The cases that we find is where we didn't consider some cases completely in the initial development, and in which case we'll go back and we'll identify it, we'll fix it, we'll add a unit test in for
Yeah.
something we didn't handle. Right?
But I mean,
Um,
sure. But once you fix it, are you concerned that it'll break again, or is that yet another thing you missed and it's another problem? Right? I don't see things that we
no,
considered all of a sudden not working.
no. If it was considered, it generally always.
Yeah, which is
I
great.
guess
That is your
one of the
safety
things,
net.
right?
Why do you have
So
why do you have an automated set of thousands of unit tests? Because you're always dealing with a house of cards with heavy amount of coupling, with no sign of OCP, with no additive only changes. That's why you need to have these spinning plates of thousands of unit tests, giving you making the walking on eggshells a little bit less painful.
so I mean, honestly, I found that most of the projects I've been with that are in real trouble. I've done lots of quote unquote regular development. I've done lots of conversions.
Mm-hmm.
And I generally find the ones that are worse off don't have the unit test, right? It's
Well, it's a
really.
traditional systems without unit tests because now, yeah, or shitty unit tests, or yeah, badly automated acceptance
Can't
tests where they
write,
try to align the
right?
planets and spin up portions
Yeah, and
of
you
the
just you
production,
can't
right?
write good unit tests.
Yeah,
I actually really think the power and simplicity of the tests that you can write come from the event model because you capture the user intent so well, right?
yeah.
So by
It's an
doing
outlet
event
for
modeling,
clear requirements, right? People don't realize that. Okay,
right?
why is event modeling so effective? It's because you're actually getting clear requirements. It's not that event modeling is good; is that it's enabling people to be good at stating what they want, which people underestimate. They're like, oh, just let the developers figure that out, and then, oh, but it's not what I asked for. It's like you didn't ask for anything. You're getting
But also,
you're rolling the dice for what you're gonna get.
right? But it also, with the rigor of the event modeling, right, and in that measure drawing thing, it forces you to find out, well, I can't do this thing you asked for without this previous piece of information. Oh,
Right.
yeah, I forgot about that. Oh, yeah, I forgot about that. And it forces this completeness on them to say, where is all this data coming from?
Yeah, no, that
How
is
this decision being made?
I'm glad we're getting
Right.
to this topic, because this is the most important aspect, is what you brought to event modeling, is being able to really look at it through that accounting lens to that level of like, where the hell did this piece of information come from? One of the most important parts of the event model being a design document is being able to very quickly say that, hey, you're making shit up. This thing appeared out of nowhere here. You're gonna have a world of hurt 3 months in when you get to this part, and you have only yourself to blame because you didn't do the check.
To circle back to the dynamic context boundaries, right?
Yeah.
I think, this really struck something with me just now in the moment. Because I was doing generally that approach of like, I would say, okay, what do I need to do? What's my actual constraint?
Mm-hmm.
What do I need to be able to satisfy the constraint? So what do I need to know? What do I need to decide on? What do I need to emit? And then I would use that to build out my chains.
Right.
Right? And I was doing this in an ad hoc manner. It's just what I did as I looked at a model. And my team would be like, well, how did Chris do that? And then when you showed event modeling, I was like, oh, this is how I get my whole team to see what I've been doing in an ad hoc way. But that same concept of what's the constraint? What do I need to know? What do I need to emit? That's what dynamic context boundaries are trying to do.
Yeah.
And that's how I define my aggregates.
Mm-hmm.
I do my workflow first. I identify the constraints I need.
Exactly.
First, and then you group your constraints into aggregates, right? You don't build aggregates and then figure out what constraints you have, because that's how you get everything in there.
Yeah.
Do your flow, find your constraints, find out what matters, and then your aggregates become obvious.
Yeah, and that
pieces of data go together.
And this was the thing, is that there was a lot of subjectivity, right? Because we said in a traditional development, it was like, well, we got to come up with really good abstractions. We have, back in OO, it was the noun for the object and class. And
what's all the data that goes in the table?
Yeah.
What are all the attributes? And it's like, no. Because all I care about are what the attributes I need to make the decision. Because I have state carrying events and I have decision events.
Yeah.
And I also found that applying the third normal form principles from proper database modeling to say only have what you need.
Exactly.
If you don't need it, don't include it. Don't include optionals. Don't include nulls. The only thing on the event, the only thing in the aggregate, the only thing in the stream is what you need.
Yeah, exactly. And it's also like, it's letting the information flow talk for itself. It's taking this subject, back to this idea that is that, we're leaning on like, oh, we have really smart developers, really smart architects. We really need them to make these abstractions. No, the business already has the abstractions. They already have the goals. It's like, this user needs to see this information. That is your source of truth, not how someone is going to make the almighty single model that's going to serve everything the business could ever possibly want and currently wants. It's really about what can we empirically ascertain that the information flow demands of us. And now what that pushes you into, and how it pushes you into event sourcing, is that I need to support multiple models. Is it easier for me to support multiple models with the traditional third normal form databases and object-oriented programming, or is it better to think about it as information flow through a system where you're capturing data at the boundary in systems thinking and projecting that to whatever you need? Obviously, the answer is the second one. And like more and more people just have to take this red pill and step out of the pod in the matrix and realize that you're saving yourself a world of hurt. Or you can play the game, where there's still money to be made. There's still tools sold for database migrations. There's still tools to be sold, like for tracking your work in Jira, because too many problems pop up. So you got to intermix your upcoming features with how you're going to handle shit falling apart as you add them, because the adding features actually is causing bugs because you're centralizing your abstractions and all that stuff, right? It's your choice. And eventually some people will say, okay, enough people have exited this bad way of working. Now we have to. Now we're the late adopters. Now we're past the 20% tipping point. I want to look like a dinosaur, or I want to look at someone that's doing things responsibly.
And one of the things I can do is I've got the other part of this talk. I show how a proper event sourcing model is more complete, holds more information than their normal form, right? And is completely symmetric with it. You can do the transformations, and your overall information storage load is lower.
Yeah.
Because you're not doing the other schemas. You're not having to do first normal form reporting tables. You're not having to do all these other things. There's no audit records. There's no, all these things to be able to look at past third normal form just aren't there.
Yeah.
So it's simpler. It's more efficient. It's more correct. But yeah, so.
Yeah, I mean,
So
I love this. I love, that there's certain throwbacks to doing things in a traditional way, and in those days, I remember there's a handful of times where I felt really good about a system, and those were like, oh, I have such a nice schema where I'm just doing essentially a select star to accomplish something and populate a screen. Those are good feelings. I don't have to think of a crazy where clause and tables and all sorts of things. Like, okay, those are the easy parts. How can I make more of my development work easy like this? And so what event sourcing did for me is essentially made everything like a select star, and that was this idea that we're using multiple models to accomplish everything, and this dynamic bounded context is really further supporting this idea of we have the models that perfectly fit what we're trying to do right here, instead of trying to make this God class that's going to make everything work together somehow magically. And you can't please everyone all the time, right? And not everyone can be pleased all the time with the same thing. So you have to build separate, models for what you're trying to attain at certain parts of your workflow and different parts of your business, and that mentality is not served well by the traditional approach. And so anyway,
people hear the multiple models, they think it's more work, and it's actually way less.
It's the opposite, because there's way more work trying to come up with something that's going to satisfy too many things, and you can have, this is just common sense. You can see this in society and human interactions. You try to, in building products, you try to build a product that's too general, that's going to have like, oh, well, everyone will want this. Well, that is the stupidest thing you could do, because there's no way that everyone's going to find this good, right? It's just not going to happen. People are different. Different people want different things at different times of their lives, and all this. These are changing needs. So you need to have things that are purpose built. That's why people have toolboxes, right? They have. You don't go with hammer and nails to build a whole house. You have all sorts of things, because attaching this, supporting beam is different than attaching the drywall. You can't use the same thing for both. I mean, you could, but man, it's going to be an ugly looking house. It'll look like Lego or something. Did we actually want to look at Allard's post on LinkedIn? You had it kind of propped up.
We can pull it up.
Yeah, because he's had. He is the CTO of Axon, and Axon is one of the event sourcing framework companies that's really pushed the event sourcing tooling that people sometimes want to use. They want to use a framework off the shelf, and so now we're seeing this, dynamically bound context in here. So I'm just going to switch screens here so that you can see. Do you want to zoom that in a bit more, the Control Plus, just so it's readable for people on phones? Some people watch this on a phone, I guess. That sort of works.
It's not really gonna.
Okay, Control.
Yeah.
So
that's about as far as it works before it starts.
Does he have a diagram down there somewhere?
No.
No. Okay.
So
anyway, I mean,
what he's talking about here is, the difficulty in changing aggregate boundaries, right?
Yes.
And I think one of the problems is we just haven't shared with people how to create those boundaries correctly.
Yeah.
Right, and it's if you start with default to putting things in small streams, different aggregates, and only bring things together when you need to make a decision, that's going to get you out of most of these problems.
Yeah, it's kind of
Right?
like Yagni, right? As well, like it's people have, oh, we're all agile. Meanwhile, they're doing the opposite of agile for how they think about systems. That they need to have,
Yep.
this upfront abstraction that's going to serve everything later. But the only thing you can really
Right.
do is build things as you need them, and have good accountability for what information
Yep.
your system's tracking, and then project that information accordingly.
And the other thing is people don't realize that in a well-factored event source system, nothing besides that aggregate and the read models are going to care about the event schema,
Yeah,
right? So you can safely recast a stream or a set of streams much more simply than people think that they can. You can really just take one section of your database and recast and rewrite it and reuse it. So it's very possible to do lots of transformations on your data. And a lot of it's the framework or the tooling's fault to not make that easy. Because really at the bottom, it's quite straightforward to do it. But we need to let that information get out there and support it more in different frameworks.
yeah. Yeah, exactly. And I'm not even sure. Like, I mean, I'm of the mindset that you don't need a framework. I'm of the mindset that you don't even need an event store specific database. I think a lot of people will come to the realization eventually that they would have been better off doing flat files and really building the things they need from scratch, because there is this open close principle. If it does work now, it'll continue to work, which is incredibly powerful. So for the clients that we have that are advanced enough into event sourcing, I put that on the table. And I think a lot of people have said, don't build your own event store. I'm actually seeing that unwind. This is our 10th year in business, and I don't, let me switch back to our regular thing here. But yeah, and the reason I say that is because I'm uncovering so much more simplicity, that you can always get out of a jam no matter what you do in event sourcing. And I think there's a lot of initial quote unquote horror stories about event sourcing were really about horror stories about CQRS, where people were really getting stuck on the pub sub, and they were getting stuck letting go of the locking part, not really embracing eventual consistency, and understanding that they can just have the end goal, the projection of how information is going to be presented. That's actually a better place to solve some of these problems. The place where you still don't solve the problem is by locking, and we can't allow bad data to enter the system. Yes, that's true. But what if you made your system so resilient that even if you do have quote unquote bad data coming in, it's still resilient, right? And I think that mind shift has really allowed a lot more flexibility, a lot more integrity actually to the systems. Because there will be mistakes. Like, hey, even if I do have the mindset of no bad data, right? There will be mistakes. It won't be just by implementation. It'll be by giving the wrong requirements, by having the wrong idea from the business angle. Like, these can come from all sorts of areas. And so why resist it? Like, it's almost like you're fighting something that you will never defeat. And so, yeah. Anyway, that's my kind of...
actually have... Part of the problem is you don't ever have... People are trying to deal with eventual consistency. And if you read the definition, it's that the state will vary until it resolves.
Yeah.
And that's never actually the case with event sourced. What I refer to as ordered consistency.
Mm-hmm.
because the state will always progress in an ordered fashion through the events. So you're either going to be stale or you're going to be current.
Yeah.
And that's very different from being in an invalid state.
Yes.
Because that I can deal with simply by dealing with an SLA. Right?
Yeah.
And so I do think that there's I should probably come back and walk through my thermal form parallels, because one of the things I found that people really like there is you can quantify the rules around good events. You can quantify the rules around good aggregates and good stream design, right? And it's not just a black art.
Yeah.
You can use the tools that we've all learned in data, because 40 years of data science has a lot of good stuff in it. The only thing we have to say is it's not only, relational databases.
Yeah.
Right? We need to you go back to COD, you look at the tuple, you look and say, okay, we're going to organize the tuples in a different way.
Yeah.
It's really nice to organize all your tuples by schema, right? And then join schema sets, and that's relational data. But it's also really good to organize tuples by time streams, right? And group them by categories and not by schema.
Right.
And that's what event sourcing is, right? If you really look at it from the abstract fundamentals, it's a change in the physical storage and the grouping of the tuples. Preserve ordering and then relaxing the constraint, which is simply about, convenience in creating a table of like-minded schema.
Yeah.
And that was just because they were saving current state for space considerations.
Yeah.
But it is half past, and I do need to get going.
Yeah, no, this has been fun. We should do this. We should do this again. And I don't know if people come back with some questions. Chris, you're on the Discord along with me for the event modeling Discord. And if you just go to eventmodeling.org, there's a resources page where you can join. Chris is on there. I'm on there. So if you're watching this stream later on YouTube or wherever as a recording and you have questions, join us there. We will also probably answer this on the comments on LinkedIn and X and other places where we're streaming. So again, Chris is one of the foremost experts on indexing and all this type of topic, this eventual consistency. He knows how the internals of DynamoDB work, and Paxos and Raft and other consensus algorithms. So he's been the core of scaling really large systems and making sure that they're running perfectly, and all sizes of companies, all the way to ones that are in charge of billions of dollars. And so definitely post your questions. You're going to get a really good answer. So
I also know how to do the simple stuff as well. So
yeah, well, of course, yes. I mean, that's
because otherwise you overbuild too much.
Yeah, exactly. I know your answer is going to be, this is actually a simple solution, and you should do the simple thing. So yeah, you're not gonna. Yeah, don't worry. Chris is not gonna push you into anything expensive. He's gonna give you the reason why things should be kept simple and why you shouldn't spend a lot of money on things. So, and again, check out Power Models and keep on the lookout for more announcements, especially if you're in the fintech area. And you obviously are using spreadsheets. Sorry, Chris, go ahead.
It's just helping you run your business.
Yeah.
Seeing the story of your business, past, present, and future, and knowing how to make good decisions, and not fighting with your accounting system on how you can understand what's going on and what does it mean, right?
Yeah. Yeah. So I'm actually very excited to see more out of Power Models, and I know that Chris's work supports that initiative really, really well. And if I was to work in that fintech space, I would want Chris and his company at my side, helping me scale that business and make sure that we're doing things in an accountable way that de-risks our operations. And so, yeah, definitely check that out. And thanks for tuning in, and looking forward to your questions. And we'll definitely have Chris back in a week or so, whenever we can have a round 2, especially if we get a lot of feedback. If you want to cover some of these things that we said, it'd be really awesome to do this again. So thanks, Chris. This is the first try of this live streaming with someone. I think Discord did a good job. I was going to do Zoom or something, but I think I'm happy with this. So anyway, thanks everyone. Thanks, Chris. And we'll see you guys online.
Thank you.